Okay, our last group for central atoms is group 6. So group 6 central atom. Our example for group 6 central atoms is going to be working with oxygen. So here we are, group 6 of the representative metals, and we're looking at oxygen. So our example atom is oxygen. And our example substance, let's use, we're going to use water. H2O. Okay, so let's go ahead and start off by estimating or predicting what we think this is going to look like. And what do we want to know? We want to know, does this substance behave like a nonpolar molecule? So in order to know that, we need to know its Lewis structure. We want to know bond type. After we know bond type, we want to know if it's symmetrical. Does it have symmetry? What is its shape? And as a result of that then, what is the substance type? What's the substance type going to be? Okay, so let's look first at this Lewis structure. All right, so I'm going to know which one goes in the center. Well, the element closer to carbon will go in the center. So periodic table, here's oxygen, here's carbon. Oxygen's closer to carbon, and hydrogen only makes one bond, so oxygen has to go in the center. So I put oxygen in the center, and then I have two hydrogens, so I'm going to place them on opposite sides so that they are equally distributed around the central atom. So hydrogen, hydrogen. After I do that, I'm going to figure out how many valence electrons am I working with. So oxygen has 6 valence electrons. There is one of them in this compound. Hydrogen has 1 valence electron, and I have 2 of them. So I have a total of 8. 8 electrons total. Okay, so let's start by putting them into bonds. So bond number 1, 1, 2, 3, 4. And then the hydrogens are full, so now I put the remaining electrons around the oxygen atom. 5, 6, 7, 8. Okay, great. So we've drawn its Lewis structure. This is what the Lewis structure looks like. Now I need to know something about the bond types. So the bonds present in this are hydrogen-oxygen bonds. These are two nonmetal, a nonmetal bonded to a nonmetal, which means this is a polar covalent bond. Two different nonmetals bonded together make a polar covalent bond. And let's look more at this concept of symmetry. What's actually happening here with our symmetry? So I have 2 hydrogens and two lone pair. So if I look at this, 2 hydrogens. So let's say that these yellows here are hydrogens, and this is my oxygen atom in the center. And I want to know, is this symmetrical? Well, what's actually happening here? Well, I had 2 hydrogens and 2 lone pair. And these hydrogens are not linear. They're not straight across like in HF, like boom, linear. This is like hydrogen fluorine. This is a linear compound. It's not linear because I have 2 lone pair on oxygen, and VSEPR theory says these electron clouds they have space, they have charge, and they repel my other atoms away from them. So in this molecule, my shape that I actually get is not linear. It's not a straight line. It's bent. So the shape is, so is it symmetrical? Well, no, it's not. Because here I have an area of negative charge, and here I have an area of partial positive charge, and I can't cut this and make this into a symmetrical shape. So it's not equally distributed charge in all directions because I have no other hydrogens bonded up here. So symmetrical? Nope. No, it is not. Which means this is going to behave like a polar covalent substance, which that's fantastic. I think we kind of knew that because we knew that water has areas of partial negative and partial positive charges, which is why it can act like it has little magnets inside of it. So symmetry, nope. It's a polar covalent substance because there is no symmetry. And then our next question was shape. What shape does it have? And we call this shape bent. It's just called a bent shape because it should have been a line, but these electrons push them down. So now instead we have a bent shape. So when we have group 6 central atoms, we may get these bent shapes with oxygen. Don't forget about drawing in lone pairs on central atoms.